What's up, Swerchesky here with another video. In today's video, we're going to be doing the practice test for our unit on rational functions. I'm going to try to go a little slower here. So let's begin. Number one. So it says evaluate each rational expression. It gives me a function f of x, and I'm supposed to evaluate it at f of 1. So what that means is everywhere I see an X, I put in a 1. Here we go. Now, you can simplify these things separately. I'm going to take advantage of something here. I notice 1 minus 1 in the denominator. It's going to give me 0 times anything is 0. So that is going to give me an answer, which is undefined. All right, let's try the next one here. So I encourage you to pause the video, try this problem on your own. I'm going to assume you have paused it. So here we go. Everywhere I see that X, I plug in a -2. I like to use parentheses here so that if I am using a calculator and I plug it in, especially when that thing is negative, doesn't give me any weird errors. So this is going to be 4 plus 4 minus 4 over 4. 4 plus 4 is 8. 8 minus 4 is 4, and 4 over 4 equals 1. Okay, so let's look at number 2 here. So it says to find the vertical asymptotes, horizontal asymptotes, and or whole. If none, write none. So here, let's start with the vertical asymptotes. So neither one of these linear factors is going to be canceled because there's no x minus 5 or x plus 2 in the numerator. So we're going to have vertical asymptotes when these factors equal 0, or when the denominator equals 0. So one will be at x equals 5. The other will be when x plus 2 equals 0, which will happen when x is -2. All right, now for the horizontal asymptote, I have to think what the degree will be. So since there's 2 linear factors here, if I were to multiply that out, I would get a degree 2 polynomial, and I would have degree 1 in the numerator. Since the degree in the bottom is larger than the numerator, I will have a horizontal asymptote at y equals 0. There's not going to be a whole because none of the factors was repeated. Okay, now I have a little bit more of a challenging one. I have to factor this. If you see here in the top, this is a GCF of 4x, and then I would have x minus 3, and that would be over, this is a difference of 2 squares. So we've seen this many times. This will factor to x plus 3 times x minus 3. Okay, now vertical asymptote. Look, these are going to cancel. So actually, let's look at the whole first. The whole will happen when x minus 3, which is what canceled, equals 0, which will be when x equals 3. So a hole will occur at x equals 3. I don't need that parentheses. The vertical asymptote will be at this factor that did not get canceled, which is x. So that will be 0 when x is negative 3. And then the horizontal will happen at the, since this is degree 2, and this is degree 2. It'll occur since the degrees are the same, it'll occur at the ratio of the coefficients. So y equals 4 is the coefficient of the top, 1 is the leading coefficient of the bottom, which is the same as 4. So that's my vertical asymptote, horizontal asymptote, and hole. All right, number 3. Vertical asymptote. Vertical is up and down. X equals negative 3. Horizontal, that's going to be at y equals 2. The domain is going to be all real numbers except when x is negative 3. So we can just write x cannot be negative 3, and for the range, y cannot be 2. If you want to write this in interval notation, I know we didn't talk about it very much in class, but you would go from negative infinity to negative 3. You'd have a union, and then you'd start back at negative 3 and go to positive infinity. And it would be very similar here. I'll let you think about that. All right. Number 4, graph the rational function and identify the key features of the graph. So let's see here. I'm gonna do this without a calculator. I'm gonna have a vertical asymptote at x equals positive 3. That's not positive. Wow. Positive 3. And then I will have a, since the degrees are the same, I will have a horizontal asymptote at the ratio of the coefficients, which will be, I'll do this in red still, at negative 2. Negative 2 over 1, which is negative 2. So vertical is x equals 3. Horizontal is y equals negative 2 over 1. And then because this a value is negative, it's going to be reflected. So it'll look like this. And the domain will be everything except for when x is 3. And the range will be everything except for when y is negative 2. Here, end behavior, as x approaches negative infinity, y or f of x will approach negative 2, and that'll happen on the right as well. As x approaches positive infinity, the function will approach negative 2. Okay. Learning target 3, write a rational function with each transformation. So remember, this is, I'll write this, let's see right here. So for a function, f of x, if we have a over x minus 8 plus k, this is going to give me left and right shifts. This will give me up or down. Let's not write that there. Let's write up or down. So if I want to be shifted up 2 units, I'll have the function 1 over x plus 2. Shifted right 6, so that'll be 1 over x minus 6 plus 8. And I will let you guys try number 7 because I don't have enough room. Okay, here the transformation will be left 7 and up 3. This would be an honors only. You can either divide this or you can kind of see that it's going to have a horizontal asymptote since the degrees are the same at um, well, at negative 9 over 1. So it's going to go down 9 and then left 3. All right, learning target 4, represent and solve simple rational equations algebraically. So I'm not going to do all these, but I will do some. You cross multiply. I'd get 3x equals 5x. Um, oh, sorry. Subtract 3x from both sides, you get 2x equals 0. X equals 0. However, if you plug in 0, it will give you a 0 in the denominator for both. So there is actually no solution here because the only solution that we had was extraneous. Extraneous. You have to always plug it back in to see if we get a extraneous solution or 0 in the denominator. Cross multiplying here on the next one. X times x gives me x squared. X times negative 3x equals, x times negative 3 is negative 3x. 2x plus 6 on the other side. So I'm going to move negative 2x over. So positive 2x becomes negative 5x. And